All right, hello again, everybody. This is part 2 on 2.4. This time, instead of just finding the linear factors and finding all the zeros, whether they're real or not, we're going to actually have to write a polynomial, okay? And you remember that the complex, what was it called? Let me back up here. Here, the conjugate root theorem, okay? The conjugate root theorem says that if a plus bi is a 0, you also have to have a minus bi, or if a plus, b square roots of c, then a minus b square roots of c has to be 1. I'm just making stuff up here for letters, but they come in conjugate pairs, okay? So it says write a polynomial function of least degree with real coefficients in standard form that has a 0 at 0 and a 0 at square root of 2 times I. What we need to realize is that if square root of 2i is a 0, negative square root of 2i is also a 0. So there's our 3 zeros. Then if we write them all as factors, linear factors, and the I is not under the radical, by the way. Okay, minus negative square root of 2i would be plus. All right, then what it says is they have to have real coefficients. So we need to multiply this together. So very carefully, x times x is x squared. X times square root of 2i would be square root of 2i times x. Then when I distribute this negative, it's going to be the same thing, negative square root of 2i times x. And then negative times a positive back here would be negative square root of 2 times square root of 2, I'm doing this one now, would be 2. And I times I would be I squared. So these two cancel each other out, and I ended up with an x squared. But minus 2i squared, remember, is really negative 2 times negative 1, which is plus 2. So there's these two factors foiled together. And then we had x minus 0, which is just an x. So this is where I would tell you you can actually stop. It says standard form, and this is not standard form. And this one's easy to put into standard form. If you just distribute that, you get an x cubed plus 2x. But sometimes at the end, you're going to get real messy answers, and we don't want to FOIL forever. So as long as you don't have any radicals or imaginary numbers left, I'm going to tell you can leave it in factored form. All right. So we're going to start this time with one that says, let's find all the complex zeros of x to the fourth minus 5x cubed plus 3x squared plus 19x minus 30, given that x plus 2i is one of the zeros. Whew. All right, if x plus 2i is a 0, I'm sorry, I can read. Wow. X equals 2 plus I is a 0, then x equals 2 minus I is a 0. Okay, a plus 1i, a minus 1i. So 2 plus 1i, 2 minus 1i are the two conjugates. All right, so what we have to do is write these as linear factors. So x minus 2 plus I, okay, times x minus 2 minus I. Now, we left those in parentheses. I'm going to go over here and work with them a little bit. So I'm going to distribute this negative, and that one's going to become x minus 2 minus I. Whoa. Sorry. And this one, when I distribute this negative, is going to become x minus 2 plus I. Now we're going to FOIL these together. This is a little bit of a painful process, guys. I'm going to distribute this x in red to all three things back there. So I'm going to have x squared minus 2x plus ix. And then I'm going to distribute in blue the negative 2 to all three things back there. So negative 2x, negative 2 times negative 2 would be 4, and negative 2 times I would be negative 2i. Then I'm going to distribute this negative I that was at the back to all three things back there. So I get a negative ix, which I'm out of room, so I'm going to write it under the like term here. And negative I times negative 2 would be plus 2i. You can write it anywhere. I just wrote it so it matched up here. And then I have negative I times I would be a negative I squared, which you can put anywhere, but I'm going to kind of put it by the 4 here because it's going to turn into a real number. All right, so whatever order you wrote all those in, go through and figure out what cancels each other out. Now, negative 2x and negative 2x is negative 4x. So I have x squared minus 4x, and then I have 4 minus I squared. All right, guys, this is a messed up recording, so I'm trying to edit here. Last time, and I don't know if the other, when I piece them together, how far I got here, but this x squared minus 2x was minus 4x, and then I said 4 minus I squared would be 4 minus negative 1, and I wrote down 4. That should be plus 5. All right, so these two zeros represent this polynomial function, and we need to divide it into our original, which is off the top here, to figure out what the other zeros are. Or we could graph it, but we're going to do this the old-fashioned way. There's a reason you have to know how to do polynomial long division. So we're going to take x squared minus 4x plus 5 and divide it into that big one up there, x to the 4th minus 5x cubed plus 3x squared plus 19x minus 30. All right. So I'm going to move this so that we can see. All right. X squared, to become exactly x to the 4th, needs to multiply by an x squared, which I then need to distribute to each of these terms out here. So I get x squared, that looks like a minus. X squared times x squared is x to the 4th. X squared times negative 4x is negative 4x cubed. X squared times 5 is plus 5x squared. Then I am subtracting all of these. So I usually mess up the signs. So I'm going to change this to plus, subtract, or a negative, plus, and a negative. So I changed this subtraction to addition, and then I distributed the negative by changing all the signs in here. Now I'm adding. So this is 0. This is negative 1x cubed. And 3x squared minus 5x squared is negative 2x squared. And I can bring down plus 19x. All right, then I go back up here and I say I need it to become exactly negative 1x cubed. So x squared to become exactly negative 1x cubed needs to multiply by negative 1 and an x. Negative 1x times x squared is negative 1x cubed. But negative 1x times this guy, 4x, would be plus 4x squared. And negative 1x times 5 is minus 5x. All right. So I am subtracting or adding the opposite of all of these. So this is 0, negative 2 and negative 4 is negative 6x squared, and 19x plus 5x is 24x, and I'm going to bring down this minus 30. Now, this needs to go in evenly because they told us in the beginning that these were zeros. That's how I figured out I messed up on the last one because it didn't go in evenly. All right, so to make finally a negative 6x squared from an x squared, I would need to multiply by negative 6. If If I distribute to all of those, I get negative 6x squared. Negative 6 times negative 4 would be plus 24x. And negative 6 times 5 is minus 30. And I need to subtract all those or add the opposite. And then those will all be 0. All right, so this is what I'm left with. I am left with x squared minus 4, or I'm sorry, minus 1x minus 6. Well, that factors x minus 3 and x plus 2 to give me a negative 6 at the back and negative 1 in the middle. So the two remaining zeros have to be at negative 2 and positive 3, or the two remaining factors are x minus 3 and x plus 2, as I wrote right here. Now, I am going to say you can stop right here. Those are the linear factors, okay? That's what they wanted. You're going to be able to stop right there. You don't need to distribute the negative even over here on these and rewrite this. I'm good with this. All right, moving on. We're going to practice writing the zeros. So this says write a polynomial function of least degree with real coefficients in standard form, but I say down here, as long as you have integer coefficients, factored form is okay. Has zeros at negative 4, positive 1, and this is a number altogether here. It's 4 plus 1, or 4 plus I. It's not a 4 and an I, it's a 4 plus I. So we need the conjugate to also be a 0. So we would have 4 minus I. In order to have a 4 plus I, there has to be a 4 minus I, which makes this a least degree as degree 4. All right, there's two easy factors. We can start our final answer over here. X plus 4 and x minus 1 will give you these two zeros. But to find the other one with real coefficients, no i's anymore, we're going to have to do some work. We're going to take we're going to take x minus 4 plus I and x minus 4 minus I. We're going to distribute those negatives. So we have x minus 4 minus I. Get rid of this parenthesis that's in here. And this one will be x minus 4 plus I. Now we're going to FOIL all this together. So I'm going to distribute the x to all these back here, which will be x squared minus 4x plus ix. Then I distribute the negative 4 to everything back in the second parenthesis, which will be a negative 4x, and I'm going to write it right under here. And negative 4 times 4, which is negative 4 times negative 4 is positive 16. And then, that didn't match up with this term, so I wrote it over here. Negative 4 times I is negative 4i. That doesn't match up with anything I have either. And you can just write them all in one big line. It doesn't matter. And then finally, negative 1 distributed to everything back here. Well, I have a negative, that's a negative I. Oh my gosh, I'm so sorry. Negative I times x is a negative ix. Negative I times negative 4 is a plus 4i. And negative I times positive I is negative I squared, which is going to turn into a real number in a minute. Great. Now it says my battery's about to die. All right, I'm going to stop and go get my charger. All right, this is my third try on this video. We'll see how it goes. It's going to be a choppy mess, I think, but I'm going to go down here and figure out what all this became. We have an x squared. Minus 4x is minus 8x. Those are 0. These like terms cancel each other out. I have 16 minus negative 1, which becomes 17 on a good day. All right, so my other factor is x squared minus 8x plus 17. because remember, it had to have integer coefficients. I could not leave it with i's. Okay, these are linear, but it's not real coefficients in standard form. What they really want is standard form, which would require that you FOILed that out, and then that you FOILed these two together, and you'd get an x to the fourth, blah, 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 blah. I don't want to go there because it's too much more room to make a mistake. Let's just stop right here. Okay? All right. Number 3 says find all complex zeros of this given that 5i is a 0, and then write the linear factorization. All right, so I know 5i is a 0, which means negative 5i is a 0, which means 2 of the linear factors are x minus 5i and x plus 5i. Okay. This says linear, so we don't have to FOIL it together. If I did FOIL it together, then I could do long division to find the remaining zeros, like we did on the last one. But this one says just graph to find the rest of the zeros. So I typed it in, okay, x to the fourth minus 8x cubed plus 16x squared plus 200x minus 225. Now this is all I got in a standard window. This is not a good window for looking at this, but I counted and this was -9, so I just did trace -9 and it actually worked. There was a 0 at -9. Then here, I tried 1 and 1 worked. So it actually had a 0 at both -9 and +1. So our other two linear factors are x plus 9 and x minus 1. Okay? I could show you the long division if we need more practice, but we found all the zeros, so that's all it really asked for. Okay? Because 5i was a 0, negative 5i had to also be a 0. So here's the zeros, here's the linear factors. All right? This one says, write each function as a product of linear and irreducible quadratic factors. Okay, this means that our answer cannot have this part right here. Means we need real coefficients. We need to factor it as far as we can factor it, okay? Then we can stop. All right. And then we're supposed to go further, sorry, and make sure they're all linear factors. So part A is without the linear factors, part B is linear factors, and then list all the zeros. Well, it's kind of backwards because we have to start really in the opposite order. So I typed this equation in, then I looked at the graph, and it appears to me I had to oh, this is what it looked like at first. There was a 0 at 4, and over here a 0 at -6, okay? But this window is really hard to tell. It looks like there's two vertical lines. So what I did was mess around with the window of the graph. I knew that a degree 4 with a positive leading coefficient meant both ends were up, but I didn't know, is this mean it's going to come back up over here somewhere? It's going to come back up over here somewhere. So what I did was I looked down further on the graph. I changed my y to a very negative number. So the y went from like 10 to -50 or something. I can't remember. Maybe even really, no, this crosses at -216. So I'm betting this graph is more like an x scale of -10 to 10. I didn't write the window down here, so. And y of like -500 to 100 or something. Okay, because this spot right here should be -216, the y-intercept. Anyway, the whole point is clearly there are only two real zeros, and there are two imaginary zeros somewhere, and we need to find those. All right, moving this over here and erasing. We are going to we're going to do successive divisions of the two real zeros that we found, which I already forgot. Should have written them down. 4 and -6. And you can do them in any order. We have 4 and -6 as two of our answers for part C, where it says list all the zeros. So I'm going to start with 4, and my coefficients are 1, 2, -15, 18, and -216. Let's double check we don't need any placeholders. This was degree 4, degree 3, degree 2, degree 1, constant. We don't need any placeholders. Okay. Very carefully, I know this has to come out 0. If it doesn't, I'm making a mistake somewhere. Bring down a 1 times 4, add, multiply, add, multiply. Oh my goodness, what is that? 44? Great, don't have a calculator here. 44 times 4 is 16, carry the 1, 16, 17. Yet this is not working. All right, so where'd Hofbauer go wrong? -15 plus 24. That's right, isn't it? 14. Oh, this is 54. All right, so the mistake wasn't too far back. I just can't add. This is 54. And again, I don't have a calculator handy. Well, I guess I could turn the one on the screen here. 21, yes, that is 216. Okay, 54 times 4 is 216. Add and you get 0. Would be an addition mistake I would make of all things. All right, then this is the successive part. You don't go back to the original polynomial. You continue dividing with your depressed polynomial here, the one that's the leftovers. So you're going to put -6 out here. And again, we could have done -6 first and then 4. It doesn't matter. You will get the same answer at the end. All right, we're going to bring down the 1 times -6. Add is 0 times -6 is 0. That's usually where I make a mistake. 9 plus 0 is 9. -6 times 9 is -54 and 0. Use your calculator if you have trouble with your facts. No shame. Okay, this is a constant. This is an x. This is an x squared because it has to be, this is your remainder. This is your constant. Power of 1, power of 2. So I have an x squared plus 9 left. Guess what? We have all of the nicely factored answers. There's the -4 was a 0, so x minus 4. -6, so that would be an x plus 6, which some reason I'm trying to squeeze in there. So this is actually the answer to A because it doesn't factor any further. Okay? So x minus 4 times x plus 6 times x squared plus 9. B says find the linear factors. Well, to do that, we need to find these two zeros. X squared plus 9 equals 0, means x squared equals -9, means x equals plus or minus the square root of -9, which is plus or minus 3i. All right, so we have up here 3i and -3i. We are now done with all of the zeros for part C. Part B wants the linear factors, so we had an x minus 4 and an x plus 6, but now we also have, I ran out of room, so I'm writing down here, x minus 3i and x minus -3i, which would become plus 3i. So those are the linear factors, meaning we're down to a power of x. These are kind of miserable, long, complicated, very algebraic if you like your algebra. All right, got one more. This one's a little bit easier in that it's only degree 3. So I typed it in, looked like this, only real 0 was at 1. Okay. The trick is, if the only 0 is at 1, I think we're missing a 0x in here, right? We're going to have a placeholder. So when we do synthetic division, we have 3x cubed plus 3x squared plus 0x minus 6. All right, we need that placeholder. Bring this down. 1 times 3 is 3. 3 plus 3 is 6. 1 times 6 is 6. 0 plus 6 is 6. 1 times 6 is 6. Negative 6 and 6 is 0. That's our remainder, so it worked. All right, so our leftovers are 3x squared plus 6x plus 6. Well, I can take a 3 out of all those. But this does not factor any further. So we are going to need to do quadratic formula to find the remaining 2 zeros. They are imaginary because they cause this little bump down here, but they don't ever show up. They're not decimals or even nice or even irrational, because irrational numbers are real and they would show up as x-intercepts, even if they were ugly decimals. So these are imaginary solutions, so we're going to get an I in our answer. All right, so I'm using quadratic formula where A is 1, B is 2, and C is 2. So I have negative B plus or minus the square root of B squared would be 4 minus 4 times A times C all over 2A, which is negative 2 plus or minus. Okay, 4 times 1 times 2 is 8. 4 minus 8 is negative 4 all over 2. So I have negative 2 plus or minus, the square root of negative 4 is 2i all over 2, which means I have to divide everything by 2. So I get negative 1 plus or minus 1i. All right, so the zeros for part C, the zeros were 1, negative 1 plus I, and negative 1 minus I. Whoa, that's not what you wrote, Hofbauer. All right, the part A would factor x minus 1. There was a 3 that we took out, so we need to include that 3. Write that better. Because remember, if I were to FOIL this back together, it's got to become this guy up here. So I had a 3 that I took out, an x minus 1. The 3 is not a 0, it's just a constant. And then x squared plus 2x plus 2. Those are the linear and irreducible quadratic factors. But then part B said write it out as linear. So I have a 3 and an x minus 1. But the other 2 factors would be from these. So I would have x minus negative 1 plus I, and x minus the other one, negative 1 minus I. And I'm going to just say it's okay to leave it just like that. We don't need to get rid of the extra parentheses by distributing the negative. Okay? Now, probably not going to ask you a question just like this on a test or quiz, but I could ask you a multiple choice part about something along the way here. So you do need to know how to do these. There's just too many steps to ask you the whole question. All right, that's, I believe, the end. Let me double check. Oh, I have 2 extra examples, and I'm going to go ahead and do them on the notes after I stop the video. Okay?